Hi. In these series of tutorial videos, we're going to look at the dihedral angle, and we're going to have an alternative approach to this. So I'm going to do a few sheets on this. So the first example I have here is two intersecting oblique planes, VTH and V1, T1 and H1 here. And the common line of intersection, we get it as normal. So we have project the intersection here A down, that's point A, and likewise B projected up, it's on the ground. Therefore, that's my intersection there. And likewise, that's the plan. Okay, I've also written the horizontal trace there, horizontal trace, and vertical trace. Okay, now, so I want to find the angle between those two planes. Okay, so here's the procedure. So first of all, I take any line perpendicular to this line of intersection down here. Okay, so that's any line, so I call it 1, 2. Then I set up an auxiliary view or a new elevation. So I set up a line parallel to AB here. There's my line, x1, y1. I project out at 90 degrees. A is at height off the ground, it doesn't change. And likewise, B is on the ground, that's it. And because this line here is lying on the ground, it's a true length. And we know that a property of looking along a true length is always going to be a point view. So therefore, when I project along here, I see point 1, 2 as a point. Okay? Now, the next thing I'm going to do is I'm going to draw a line perpendicular to the line AB. So AB in this case is a true length. Therefore, this line here is perpendicular to the true length. Okay, so now I have points 1, 2, and now I've got a third point. So that third point is going to make up my triangle. So when I project it back here, there's my triangle 1, 2, and 3. So that little triangle is inside the oblique plane and is touching a common line to the oblique plane. The next thing I'm going to do is I'm going to look at that edge of the triangle. I'm going to look along here, or if you want it, I'm going to look along the true length of the line AB. And we know that the property of looking along a true length is always going to be a point view. So when I project along here, I know I'm going to get a point view of the line AB. So where do I get that distance? Well, the distance from the x1, y1 to A is the same as from x1, y1 from B to B here. They're the exact same. So therefore, I take those distances here with my dividers or compass, and I simply step them out here. Okay. Likewise, I take points number 1 and 2 respectively. I take those as well. 2 being the furthest away. Okay. So 2 is going out there, and likewise number 1. 3 happens to be on the line AB. Therefore, 3 is actually tucked in there. Okay, so the point 3 is actually in there. When I join that up there, a couple of things happen. I actually get a triangle. And because that's the edge of a triangle there, that's the true shape of a triangle. Okay, that's my true shape, 1, 2, and 3. But it also gives me the dihedral angle, which is the angle common to both planes. Okay, so what I'm saying is this, that the dihedral angle, by definition, is the angle between two planes. And the third plane is perpendicular to these two planes. Okay, so I'll say that again. So the dihedral angle is the angle between two planes. The third plane, which is 1, 2, and 3 in my case, that plane there is perpendicular to that plane, and it is perpendicular to that plane. Okay. Another thing that I actually do as well when I'm doing these questions here, I always put down the planes of reference. So the planes of reference are, I've got my elevation here, so therefore that's a horizontal plane. This is my plan, there's a vertical plane. This view down here, I have a horizontal plane and I have a vertical plane. And likewise, over here, I've got a vertical plane and a horizontal plane. They're my planes of reference. So just to recap on how to get point AB, because we're talking about a vertical plane, that must be a new plan. Okay, and this down here is a new plan because the two V's correspond. Okay, so therefore, the distance from there to there is exactly the same from there to there, okay? Because they're both plan views. And finally, another alternative way of getting that dihedral angle, because we have an edge view up here of the triangle 1, 2, and 3, all I'm going to do is simply rotate that, having the point of the compass at point 1, 2, swing that down, okay? So point 3 is on the ground there now. I project it back parallel here, project it back, and it lands here. In other words, 3 is going to move out parallel to the x1, y1. Therefore, that dotted detail there that is the exact same angle as you got up here. I've done this by rotation. Okay, so that there is the true shape of my triangle 1, 2 and 3, and it's also the dihedral angle between the two oblique planes VTH and V1 T1 H1. And over here I've done a little sketch of the situation here. So there's my little oblique plane here, but there is just two intersecting triangles really, if you want. And there's my common line, and tucked in here then I've got my little triangle here, and I just swung that onto the ground there. So that's the actual 3D setup of what we're actually trying to achieve. Okay, thank you.